Hi, welcome to this Corbettmaths video. In this video, we're going to look at the recurring decimals practice questions. If you need any extra help on recurring decimals, if you go to corbettmaths.com/contents and scroll down to video number 96, there's a dedicated video tutorial there on recurring decimals and also how to convert recurring decimals into fractions. Alternatively, you could scan this QR code and bring you straight to that video. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, let's have a look at question number 1. So question number 1 says, shown below are 4 fractions, and our fractions are 5/8, 1/3, 2/7, and 11/20. I've been asked to circle any fractions that are recurring decimals. So since this is a calculator question, I'm just going to divide the numerators by the denominators and convert all of these fractions into decimals. So let's start off with 5/8. So 5/8. So if we do 5 divided by 8 in our calculator, or you can use the fraction button if you wish, but 5 divided by 8 would be 0.625. Now that decimal stops, so that's a terminating decimal, so not a recurring decimal. So the 5/8 is a terminating decimal, so we're not going to circle it. Now let's try 1/3. Now we should already know that 1/3 is a recurring decimal. It's 0.33333 and so on. But if I was to do 1 divided by 3 in my calculator, I would get 0.3333 and so on. And I would just carry on. Or alternatively, it could be displayed as 0.3 with a little dot above it. And remember that dot means recurring, so it just means 0.33333 and so on forever. So 1/3 is a recurring decimal, so let's circle it. So that's our first one. Okay, now 2/7, so 2/7. So if we do 2 divided by 7 on our calculator, 2 divided by 7, that's equal to 0.2857142, 28557 and so on. And as you can see, that's recurring because it goes 2857142, 28557 and so on. Alternatively, a calculator display may display it as 0.2 with a little dot above it, 85714 and another dot above that one, and that shows us that the 2855714 are recurring. So we'll just go 0.2857114, 2855714, 2855714 and so on. So 2/7 is a recurring decimal. And finally 11/20. 11/20, if we do 11 divided by 20 on our calculator, and that's equal to 0.55, and that's a terminating decimal, so it's not a recurring decimal, so we're not going to circle that one. So our two fractions that are recurring decimals would be 1/3 and 2/7. Okay, let's have a look at question number 2. So question number 2 says, write the fraction 1/6 as a recurring decimal. Now this is a non-calculator question, so we need to do 1 divided by 6. So we're going to do 1 divided by 6, and I've done my bus shelter, and I've got my 6 there, and I'm going to put a decimal point and some zeros, because I know it's a decimal number, so I'm just going to put some zeros so that whenever I'm dividing, I've got those there. And we've got our decimal point here, so let's put our decimal point there directly above it. And we'll see how many 6s go into 1, 0, remainder 1. How many 6s go into 10? Well, that's 1/6, remainder 4. How many 6s go into 40? Well, 6 6s are 36, that's going to be 6, remainder 4. And then how many 6s go into 40? 6, remainder 4, 6, remainder 4, 6, remainder 4, and so on. So that would be 0.166666, and it would just carry on like so. Or we can write it as 0.16 with a little dot above the 6. So write 1/6 as a recurring decimal, so it'd be 0.16 with a dot above the 6 to show the 6 carries on forever. Alternatively, we could write 0.166666 and so on, just to show that carries on like so. So 1/6 as a recurring decimal is either 0.16 with a little dot above the 6 or 0.166666 and just shows that goes on forever. Okay, let's have a look at question number 3. So 3a says write 2/3 as a recurring decimal. Now 1/3 was 0.33333 and so on. So 2/3 will be 0.66666 and so on, or 0.6 with a little dot above it. Now 2/3 is one that I would learn off by heart, so that it's that. Alternatively, we could use our division. We could do 2 divided by 3, dividing the numerator by the denominator. So 2 divided by 3, and we'll put a decimal point and some zeros. And we can put a decimal point above the 1 and say how many 3's go into 2? 0, remainder 2. How many 3's go into 20? Well, 3 times 6 is 18, so that's going to be 6, remainder 2, 6, remainder 2, 6, remainder 2, and so on. So it would be 0.66666 and so on, or 0.6 with a little dot above it. Okay, let's have a look at part B. So part B says, right, 2/30 is a recurring decimal. Now, here we've got 2/3 and now we've got 2/30. As you can see, the denominator is 10 times larger. So instead of dividing 2 by 3, we want to divide 2 by 30. So that means that our answer will be 10 times smaller. So rather than being 0.6666666 and so on, we're going to divide this by 10 again. And our answer would be 0.06666666 and so on, or 0.0 and then 6 and with the little dot above it. And I knew that because instead of dividing the 2 by 3, we're dividing 2 by 30. So remember, we could divide by 3 and then divide by 10, and that's the same as dividing by 30. So we just divided our answer by 10. So that's one way to do it. Alternatively, if we wanted to, we could just use the bus shelter method again and do 2 divided by 30. So 2 divided by 30. We'll put our decimal point in some zeros, and we'll put a decimal point above the other one. So how many 30s go into 2? 0, remainder 2. How many 30s go into 20? Well, there's no 30s in 20s, so 0, remainder 20. How many 30s go into 200? Well, 6 30s is 180, so it's going to be 6, remainder 20. And then how many 30s go into 200? 6, remainder 20, and it just carries on like so. So it'll be 0.0666666, and so on. So that's it. So 2 30ths as a recurring decimal would be 0.06 with the little dot above it. Okay, let's have a look at our next question, question number 4. So question number 4 says, right, 4 sevenths is a recurring decimal. So remember to change this fraction, 4 sevenths, into a recurring decimal, into a decimal. We'll divide the numerator by the denominator. So we need to do 4 divided by 7. So 4, then a decimal point and some zeros. I'm doing quite a few of them here. And we want to divide that by 7. Now, you don't necessarily need to do as many straight away, but I'm just doing that for fun. So 7. So how many 7s go into 4? So it's going to be 0, remainder 4. How many 7s go into 40? Well, 6 times 7 is 42, so it's not going to be 6, it's going to be 5. 5 7s are 35, so 5, remainder 5. How many 7s go into 50? Well, 7 times 7 is 49, so it's going to be 7, remainder 1. How many 7s go into 10? That's going to be 1, remainder 3. How many 7s go into 30? Well, 4 7s is 28, so that's going to be 4, remainder 2. How many 7s go into 20? That's going to be 2, remainder 6. How many 7s go into 60? That's going to be 8, remainder 4, because 8 7s are 56, so that's 8, remainder 4. How many 7s go into 40? That's going to be 5, remainder 5. How many 7s go into 50? That's 7, remainder 1. You can see there's a pattern forming here. How many 7s go into 10? That's 1, remainder 3. How many 7s go into 30? That's going to be 4. 4 7s are 28, remainder 2. How many 7s go into 20? That's going to be 2, remainder 6. How many 7s go into 60? Well, 7 times 8 is 56, so it's going to be 8, remainder 4, and so on. And we can just carry on, but you might notice there's a pattern here. It's 0.571428, 57148, and so on. So as you can see, it's 0.571428, 57148, and so on. Now I'm going to show your answer using the dots, so that's 0 point. And the chain that's repeating is 571428, 571428. So it's going to be 571428, and a dot above the first number and a dot above the last number. And that just means that it's 0.571428, 571428, and so on. Okay, question number 5. So question number 5 says, right, 3 11ths is a recurring decimal. So we want to divide the numerator by the denominator. So we want to do 3 divided by 11. So we've got 3, and then let's put our decimal point in some zeros. And we want to divide that by 11. So how many 11s go into 3? Well, there's no 11s in 3, remainder 3. How many 11s go into 30? Well, 2 11s is 22, so it's going to be 2, remainder 8. How many 11s go into 80? That's going to be 7. 7 11s are 77, remainder 3. How many 3s go into 30? That's 2, remainder 8. How many 11s go into 80? That's 7, remainder 3. How many 11s go into 30? That's 2, remainder 8, and so on. So as you can see, there's a pattern. It's 0.272727, and so on. So it's going to be then 7, 3, 2, and so on. So we've got 0.272727, and so on. Or using our dots, it would be 0. And the chain that's repeating is 272727. So let's write our 2 and our 7 and a dot above the 2 and a dot above the 7. So it's 0.27 with a dot above the 2 and a dot above the 7. Okay, let's have a look at question number 6. So question number 6 is circle the largest number. So let's have a look at these numbers. Well, let's look at the units or the ones column. So we've got 1, 1, 1, 1, 1, 1, 1, 1. So that's not going to help us. Then if we look at the tenths, we've got 8 tenths, 8 tenths, 8 tenths, and 8 tenths. So that's not going to help us. If we then look at the hundredths, this one's got 5 hundredths, this one's got 5 hundredths, this one's got 5 hundredths, and this one doesn't have any hundredths. So this is our smallest number. So let's cross that one out. It's not going to be 1.8. Okay, now we've got 3 numbers left. I'm actually going to write these numbers out. I was almost going to say in full. I'm not going to write them out in full because they're going forever. But let's have a look at our 1.85 with the dot above the 8 and the 5. So that's going to be 1.85 with a dot above both of them would be equal to 1 point. And then that means the 8 and the 5 repeat. So 85, 85, 85, 85, and so on forever. Our 1.85 with a dot above the 5, that would be 1.85 with a dot above the 5. That would be 1.85. And it just shows the 5 repeats. So that's 5, 5, 5, 5, 5, and so on. And we've also got our 1.85 here. Now, if we have a look at the ones of the units, they've all got 1 in the ones of the units. Now, if we look at the tenths, they've all got 8 in the tenths. They've all got 5 in the hundredths. So now let's have a look at the thousandths. So that third decimal place. So the 1.85, it doesn't have any numbers in the thousandths. It doesn't have a digit in the thousandths, so it's not going to be that one. So it means that it's between one of these two numbers. One of these two numbers is our largest. So they've both got 1s in the ones. They've both got 8 in the tenths. They've both got 5s in the hundredths. So if we look at the thousandths, 1.85 with a dot above the 8 and the 5, it has got an 8 in the thousandths, whereas 1.85 with a dot above the 5 only has a 5 in the thousandths. So that means this number is the largest and this one isn't the largest. So that's not the largest, and this one here is the largest because it's got an 8 in the thousandths. And that's it. Okay, let's have a look at our next question, question number 7. So question number 7 asks us to circle the smallest number. So we've got 0.7 reoccurring, 0.78 with a dot above the 8, 0.775, and 0.749 with a dot above the 9. So let's have a look at these numbers. So 0.7 with a dot above will be 0.7777, and so on. 0.78 with a dot above the 8 will be 0.7, and then the 8 repeats, so that's 8, 8, 8, 8, and so on. 0.775 is just 0.775, that's terminating, and 0.749 with a dot above the 9 will be 0.7499999, and so on. So we've been asked to circle the smallest number. So let's look at the ones of the units. 0, 0, 0, 0. That's not going to help us. Now let's have a look at the tenths. 7 tenths, 7 tenths, 7 tenths, and 7 tenths. Okay, that's not going to help us. Let's now have a look at the hundredths. 7 hundredths, 8 hundredths, 7 hundredths, and 4 hundredths. So that means this is the smallest number. So that's the smallest number there. 0.749 reoccurring. Okay, let's have a look at our next question, question number 8. So question number 8, we've been asked to write the following numbers in order of size, starting with the smallest number. So we've got 0.705 with the dots above the 7 and the 5, 0.705 with the dot above the 5, 0.705, just terminating, and 0.705 with a dot above the 0 and the 5. Okay, let's write these numbers out. So 0.705, 705, 705, and so on, because we've got a dot above the 7 and the 5. That means that the 705 all repeats. This one would be 0.70, and then the dots above the 5, so it'd just be 5, 5, 5, 5, 5, and so on. 0.705, that's terminating, and then we've got 0.7, and then we've got the dot above the 0 and the 5, so it's going to be 05, 05, 05, 05, and so on. So we want to put them in order of size, starting with the smallest. So let's start at the ones of the units. So 0, 0, 0, 0. That's not going to help us. Now the tenths, 7 tenths, 7 tenths, 7 tenths, 7 tenths. Okay. Okay, now let's have a look at the hundredths. 0 hundredths, 0 hundredths, 0 hundredths, 0 hundredths. No, the thousandths. 5, 5, 5, and 5. Okay, so let's have a look at the fourth decimal place. So we have got a 7, a 5, a 0, and a 0. So it's between these two in terms of our smallest number. So let's have a look at the fifth decimal place in terms of these numbers. So this one doesn't have any, but this one has a 5, so this is our smallest number. 0.705 is our smallest number. Our next smallest then would be 0.705 with a dot above the 0 and the 5, because that's obviously smaller than these two, because these numbers have 7 and 5 in the fourth decimal place, whereas this one doesn't have any. Now let's find our next biggest number. So looking at the fourth decimal places again, we had 7 in this one and 5 in this one. So then this is the next smallest, which is 0.705 with a dot above the 5. And then our largest number, which had a 7 in the fourth decimal place, would be 0.705 with a dot above the 7 and a dot above the 5. And that's it. So we've put those numbers in order, starting with the smallest. Okay, let's have a look at question number 9. So question number 9 says, write the number 0.81 with dots above the 8 and the 1, so it's a recurring decimal, as a fraction, and to give our answer in its simplest form. So we want to write this as a fraction, so I'm going to let this be called x. So I'm going to write x equals, and I'm going to write this out. I was going to say in full, but I'm going to write it out a bit more full. I'm going to write out some of the decimal places. There's 0 point, and it's with a dot above the 8 and the 1, it means they both repeat, so it's going to be 81, 81, 81, and so on. Okay, so that's x. Now we want to find another number which has the same bit after the decimal point. So we want to find another decimal number that has 81, 81, 81, 81, and so on. And we're going to times this by 10 or 100 or 1,000 and so on. Now if I times this by 10, it would be 8.18181818. And that's not 81, 81, 81, 81. So I'm not going to multiply this by 10. I'm actually going to multiply by 100. So if I multiplied x by 100, that would give me 100x. And 100x would be, if I multiply this by 100, moving all the digits 2 columns to the left, would be 81.818181 and so on. Now both these numbers are 0.818181 and are 81.818181 have the same bit after the decimal point. So if we were to take those numbers away from each other, the bits after the decimal point would disappear, they'd all become 0, and we'd just be left with a number equals so many x, and then we can divide and find out what x is. So whenever we're taking these away from each other, I'm going to write the x beneath because I want to have the larger one above, so that's going to be 0.818181 and so on. And 100x take away, let's write down when we're taking them away, so subtract. So 100x take away x, but that'd be 99x. And then we've got 81.818181 take away 0.818181 and so on. That's just going to be 81, so it would just be 81. Now we've got 99x is equal to 81. Now think about solving an equation, you would want to get the x on its own. So let's divide both sides by 99. So divide by 99 and divide by 99. Now if we divide the left hand side by 99, we're doing that to get rid of the multiply by 99. So we'd just be left with x. And on the right hand side we had 81 divided by 99. Now we want to write this as a fraction, so we're just going to write 81 over or divided by 99. So that means that x is equal to 81 over 99. Now we want to give our answer in its simplest form, and this fraction can be simplified because if we look, 81's in the 9 times tables and 99's in the 9 times tables. So let's divide both the numerator and the denominator by 9. So x equals, so if we do 81 divided by 9, that's 9. And if we do 99 divided by 9, that's 11. So that means our answer is 9/11ths. So the number 0.81 with dots above the 8 and the 1 as a fraction would be 9/11ths. Okay, let's have a look at question number 10. Okay, question number 10. So question number 10 says to convert the number 0.34 with a dot above the 4, so that's 0.344444 and so on, to a fraction, and to give our answer in its simplest form. So let's let this be x. So we're going to write x equals, and I'm just going to write this out as 0.344444 and so on. Now here we've got 0.344444 and so on. Now, whenever we're changing our recurring decimals into fractions, it's great if we can just have the recurring bit after the decimal point. So here we've got 0.3, and then we've got 44444 and so on. It'd be great if the 3 wasn't there and we just had the 0.44444 and so on. So if we multiply this by 10, we would get, multiplying both of these by 10, we would get 10x on the left-hand side. And on the right-hand side, if we times this by 10, we would get 3.44444 and so on. Now that's great because we have just got the recurring bit after the decimal point. Now what would be fantastic is if we had another number which had the same bit after the decimal point, so the same recurring bit after the decimal point. So if we multiply both of these by 10 again, we would get 100x, or to multiply both of these by 100, you get 100x equals, and instead of 3.44444 and so on, we would have 34.4444 and so on. Now that's fantastic because we've now got two numbers with the recurring bit after the decimal point. So we're going to take them away from each other. So we've got 100x, let's write 10x beneath it. So 10x equals, and we have 10x is equal to 3.4444 and so on. Now we want to take these away from each other so that the recurring bit after the decimal point just becomes 0 or disappears. So we have got, if we take these away from each other, so subtract, 100x, take away 10x, that would be 90x. And then on the right hand side we had 34.4444 and we're taking away 3.4444 and so on. That's just going to leave us with 31. So we've got 90x is equal to 31. That's fantastic. We can divide both sides of this equation by 90 and find out what x is. So divide by 90 and divide by 90, and we'll get on the left hand side x, and on the right hand side we'll have 31 divided by 90, so that's 31 over 90. And 31 over 90 can't be cancelled down, so the answer would just be 31/90ths. So 0.34444 and so on, or 0.34 with a dot above the 4 as a fraction would be 31/90ths. Okay, let's have a look at our next question, question number 11. So question number 11, we've been asked to prove algebraically the 0.512 with a dot above the 1 and the 2, so that's 0.512121212 and so on, can be written as 169 over 330. So let's start off by calling this x, so x equals, and I'm going to write it as 0.512121212 and so on. Now, I want to have a number which has just the recurring bit after the decimal point, that 1, 2, 1, 2, 1, 2. So I'm going to times this by 10 because I want to move this 5 over to here. So it's going to be 10x equals, and if I multiply this by 10, I would get, moving all the digits one column to the left, would be 5.12121212, and so on. Now that's fantastic because we have a number now with the recurring bit after the decimal point. Now if we go back up to our x, we've times this by 10 to get 5.12121212. Now let's figure out what we could times this by to get another number with the 121212 after the decimal point. Now if we moved all the digits 3 columns to the left, you would then have 512.12121212. So if we want to move the digits 3 columns to the left, or the decimal place 3 columns to the right, we would multiply this number by 1,000. So if we times this by 1,000, we would get 1,000 x is equal to, moving the digits 3 columns to the left would be 512.12121212, and so on. So that's what we get if we times that by 1,000. That's fantastic because we've now got 10x and 1,000x, and both of those numbers have got the 12121212 after the decimal point. So we have got 1,000x equals, and we've got 10x equals, and 10x is equal to 5.12121212, and so on. So we've got 1,000x equals and 10x equals. Now let's take them away to see what we get. So 1,000x take away 10x. Let's write down we're subtracting. Subtract. 1,000x take away 10x would be 990x. And on the right hand side, we'd have 512.121212, and we're taking away 5.121212. Well, the bits after the decimal point would all become 0, so we're left with 512 to take away 5, which would be equal to 507. So we've now got, I'm just going to go up here, 990x is equal to 507. We want to get the x on its own, so let's divide both sides by 990. So divide by 990 and 990. So we get on the left-hand side, x. And on the right-hand side, we've got 507 divided by 990. Now that's almost what we want. What we want is 169 over 330, but this is over 990, so I can see we're dividing by 3. So this fraction can be cancelled down, and it can be cancelled down by dividing both the numerator and denominator by 3. So dividing the denominator by 3 would be 330. That's fantastic. So let's just divide the numerator by 3 and check it's equal to 169. So 507 divided by 3. 3 into 5 goes once, remainder 2. 3 into 20 would go 6 times, remainder 2, and 3 into 27 goes 9 times, so that's 169. That's fantastic. So that means that x is equal to 169 over 330, and that's it. Okay, let's have a look at our next question, question number 12. So question number 12 says, convert the number 0.451515151 and so on to a fraction and to give our answer in its simplest form. So let's let this be equal to x, so x equals 0.4515151 and so on. Now we want a number that has just that recurring bit after the decimal point, so that's the 515151 and so on. So let's multiply this by 10 to get 10x equals, and multiplying this by 10 will be 4.515151 and so on. Now if we go back up to our x, we want another number which would also have the 515151 and so on after the decimal point. So we go back up to our x, we have 0.4 and then we've got 515151 and so on. Now if we multiply this by 10, we get our 4.5151 and so on. Now let's consider another number we can multiply this by. Now if we move all the digits 3 columns to the left, we would have 451.515151 and so on. So I'll be multiplying this by 1,000 to move all the digits 3 columns to the left. So that would be 1,000x is equal to 451.515151 and so on. So we've got 10x and 1,000x, and both of them have that 515151 after the decimal point. So now let's take them away from each other. So let's write 10x equals 4.515115 and so on. And we're going to take them away, so subtract. 1,000x, take away 10x, that would be 990. X, and on the right hand side we have 451.515151 and so on. We've then got 4.515151 and so on. If we take them away, the bits after the decimal point would all become 0, so that's just going to disappear. And we've got 451 take away 4, so it's going to be 447. So if we divide both sides, let's write this equation up here actually, 990x equals 447. And if we divide both sides by 990 and 990, that would give us on the left hand side x, and on the right hand side we'd have 447 over 990. Now we've been asked to give our answer in its simplest form, so we need to cancel this down. Well, they're not both even, this one's odd and this one's even, so we can't divide by 2. Let's see if we can divide both of them by 3. So if we, to check and see if a number is divisible by 3, if you add the the digits together, they will add together to be a multiple of 3. Well, 4 plus 4 plus 7, so 4 plus 4 is equal to 8, plus 7 is equal to 15, and 15 is in the 3 times table, so you can divide that by 3. And 9 plus 9 is 18, plus 0 is 18, and 18 is in the 3 times tables as well. That means we can divide both the numerator and the denominator by 3. And I just added the digits together, and if the digits add together to be a number in the 3 times tables, it's divisible by 3. So let's divide both the numerator and the denominator by 3 and see what we get. So the denominator, 990, divided by 3 would be 330. And let's divide the numerator by 3, so 447 divided by 3. So 3 into 4 goes once, remainder 1. 3 into 14, well, 3 times 4 is 12, so it's going to be 4, remainder 2. And 3 into 27 goes 9 times. So if we divide 447 by 3, the answer would be 149. So that means if we divide, that means that's 149 over 330. Now let's just check. We can't divide these by 2. If we check, see if we can divide them by 3, 1 plus 4 plus 9 is equal to 14. That's not on the 3 times table, so we can't divide by 3 again. We can't divide by 4. We can't divide by 5. And actually, that's as far as we can go. So our answer is 149 over 330. And that's it. Okay, let's have a look at question number 13. So question number 13 says, write the number 1.24 with a little dot above the 4, so that's 1.244444 and so on. So that's 1.244444 and so on. And we've been asked to write that as a mixed number and to give our answer in its simplest form. So let's let that be equal to x. So we've got x equals 1.244444 and so on. We want to write this as a mixed number. So to write it as a mixed number, I want to write it as a fraction to begin with, a top every fraction, and then I can change it into a mixed number. So let's change this into a fraction. So we want the recurring bit after the decimal point, so we're going to multiply by 10. So 10x equals 12.4444 and so on. Now let's multiply by 10 again. That would give us 100x is equal to 124.4444 and so on. So we've got two numbers with the recurring bit after the decimal point. We've got 100x equals 124.4444 and so on. And we've got 10x is equal to 12.4444 and so on. So let's write the 10x beneath the 100x. So that's 12.4444 and so on. And we're going to take them away from each other, so subtract. So 100x take away 10x would be 90x. And on the right hand side, we had 124.444. We're taking away 12.444. Well, the decimal bits are all going to become zeros, so that's just going to disappear. So we're left with 124, take away 12, so that would be 112. So we've got 90x equals 112. Now, if we divide by 90 and divide by 90, we would get on the left hand side x, and on the right hand side we'd have 112 divided by 90, so that's 112 over 90. So it means that x is equal to 112 over 90. Now we want to write this as a mixed number and in its simplest form. So let's write it as a mixed number to begin with. So how many 90s go into 112? That would be 1, and our remainder would be 22. So it'd be 22 over 90. Now the 22 over 90 can be cancelled down. Let's start off by half on them, so that'd be 1, and dividing both of these by 2 would be 11 over 45. And that's it. So the answer would be 1 and 11 over 45, or 1 and 11 45ths. And that's it. Okay, let's have a look at question number 14. So question number 14 says, prove algebraically the 0.309 with a dot above the 0 and the 9, so it's 0.309090909 and so on, can be written as 17/55. So let's write that down to begin with. So 0.3090909 and so on, and that's equal to x. Now we want to have the recurring bit after the decimal points, that would be the 090909 and so on. So let's write 10x. So 10x is equal to 3.090909 and so on. So we've got a number with the recurring bit after the decimal point. Now let's go back up to our x and find another one with that 090909. So if we moved all the digits 3 columns to the left, that'll be 309.090909. And we want to move the digits 3 columns to the left, so that'll be multiplied by 1,000. So that'll be 1,000x is equal to 309.090909 and so on. So that's fantastic. We've got two numbers with that 090909 and so on after the decimal point. So we've got our 1000x and our 10x. Now let's take them away. So subtract. 1000x take away 10x, that'll be 990. x. And on the right hand side, we've got 309.090909, and we're taking away 3.090909. That's 090909, that would all become 0. So left with 309, take away 3 would be 306. So we've got 990x equals 306. So let's divide both sides. Actually, let's write up here to begin with. 990x equals 306. So let's divide both sides by 990. So divide by 990 and divide by 990. So on the left-hand side, that would just leave us with x. And on the right-hand side, we get 306 over 990. Okay, so we now want to cancel this down, and hopefully it'll cancel down to 17/55. So we've got 306 and 990. Hopefully that'll cancel down to 17/55. Now if we have a look here, both of these numbers are divisible by 2. They're divisible by 3. I can actually see they're divisible by 9 because the divisibility test to see if numbers are divisible by 9 are add the digits together and see if you get a multiple of 9. So 3 plus 0 plus 6 is 9, and 9 plus 9 plus 0 is 18, and they're both in the 9 times tables. So that means that both of these numbers are divisible by 9. So let's divide both of them by 9. The numerator, if we divide that by 9, would be 110. And the numerator, if we do 306 divided by 9, 9 into 3 goes 0, remainder 3 times. How many 9s go into 30? That's going to be 3, which is 27, remainder 3. And how many 9s go into 36? That's going to be 4. So that means if 306 divided by 9 is 34. So we'll have 34 over 110. Now we want 17 over 55. We can half both of these to get 17 over 55. And that's it, we're done. So we've shown that 0.309090909 can be written as 17/55. Okay, let's have a look at our next question. So question number 15. Question number 15 says to prove algebraically that 0.21666666 and so on can be written as 13/60. So that's 0.21666666 and so on. And well, let that be equal to x. And we want to get a number that has that recurring bit after the decimal point. So that's the 66666 and so on. So let's multiply both of these numbers by 100. Because if we multiply both of these numbers by 100, we get 100x is equal to, and if we move all the digits 2 columns to the left, would be 21.66666 and so on. So that's 100x. Now, if we go back up to our number x, we want another number that has that 66666 and so on after the decimal point. So instead of multiplying by 100 to get 21.66666, we could multiply by 1000, and that would be 1000x is equal to 216.66666 and so on. So we've got 100x and 1000x. So if we take them away, so let's write the 100x beneath. 1000x take away 100x, that would be 900. X, and on the right hand side we had 216.66666 and so on. We're taking away 21.66666 and so on. Well, all the bits after the decimal point will cancel out, they'll just become zeros. So you're left with 216, take away 21, that'll be 195. So we've got 900x equals 195. So let's write that down. 900x is equal to 195. Now we want to get x on its own, so let's divide by 900 and divide by 900. So on the left hand side we'd be left with x, and on the right hand side we'd have 195 over 900. Now we want to cancel that down to hopefully 13/60. Now the first thing I notice is both of these numbers are in the 5 times table, so both multiples of 5, the 195 and the 900. So let's divide both of them by 5. So if we do 195 divided by 5, 5 into 1 doesn't go, remainder 1. 5 into 19 goes 3 times, remainder 4, and 5 into 45 goes 9 times. So it's going to be 39 on the numerator. And in terms of the denominator, we're going to do 900 divided by 5. Well, 5 into 9 goes once, remainder 4. 5 into 40 goes 8 times, and 5 into 0. So that's going to be 180 on the denominator. Now we want to get 13 over 60. Now we've got 180 on the denominator. So that means that we should be able to divide by 3, because if we divide 180 by 3, we would get 60. So let's take our 39 over 180 and divide both the numerator and the denominator by 3. So on the denominator, 180 divided by 3 is 60. And in terms of our numerator, 39 divided by 3 would be 13. So that would be 13 over 60. And that's it, 13/60. Okay, let's have a look at question number 16. So question number 16, we've been asked to write the number 2.165656565 as a mixed number and to give our answer in its simplest form. So 2.1656565 and so on. And that's x. So we've got what x is, and we want to get a number which has that recurring bit after the decimal point. So let's times it by 10. So 10x equals 21.656565 and so on. So we've got 10x, and that's equal to 21.656565 and so on. Now we want to get another number that has that 656565. So let's go back up to our x, and we want to have a number that has got 656565. Now we've got 21.656565. So if we had 2165.656565, that'll be great. So that would be moving all the digits 3 columns to the left. So that means that'll be 1000x. So 1000x is equal to, if we times this by 1000, it'll be 2165.656565 and so on. So we now want to get, well, we've got 1000x and 10x. If we take them away, that'll get rid of the bits after the decimal point. So let's write down our 10x. So 10x equals 21.656565 and so on. And if we take them away, 1000x, take away 10x, that's 990x. And on the right hand side, we had 2165.656565 and so on. And we take away 21.656565. Well, the 656565 will cancel. So we're left with 2165, take away 21, which would be 2144. So we've now got 990x equals 2144. So if we divide both sides by 990, that will give us what x is. So on our left hand side we'd have x, and on our right hand side we'd have 2144 over 990. So we've been asked to give this as a mixed number and to give our answer in its simplest form. So we're going to see if we can write it as a mixed number to begin with, what we can, and then we're going to see if we can cancel it down. So let's start off by writing it as a mixed number. So how many 990s go into 2144? So let's write down our multiples of 990. So it's going to be 990. If we add another 990, that'll be 1980. And then the next one's going to be much higher than 2144. So we know it's going to be 2. So x is equal to 2. And then in terms of our remainder, well, we've still got 990 on the denominator. And then in terms of our remainder, well, we had 2144, and we know that 2 990s is 1980. So that means if we take them away, we'll get our remainder. So 2144 take away 1980, and that's equal to 164. So we've now got that x is equal to 2 and 164 990ths. Now both of these numbers are even, so let's half both of them. So we'll get 2, and dividing both of these by 2 would give us, well, half of 164 is 82, and on the denominator, half of 990 would be 495. And that's it. And these can't be cancelled down any further, so answer would be 2 and 82 over 495. And that's it. Okay, let's have a look at our next question, question number 17. So question number 17, we've been asked to write the numbers below in order, starting with the smallest number. And we've been given 11/23, 0.4727272, and 5/11ths. So what I'm going to do is, because it's a calculator question, I'm going to convert these fractions into decimals. 0.478260 and so on. And 5/11ths is equal to, 5 divided by 11 would be equal to 0.454545 and so on. So if we have a look at our numbers, we want to see which ones are the smallest. So, and also let's write out a recurring decimal. So that's going to be 0.4727272 and so on. Okay, so let's start off by looking at the ones or the units. That's 0, 0, and 0. That's not going to help us. Let's look at the tenths, 4 tenths, 4 tenths, and 4 tenths. No. Now let's have a look at the hundredths, 7 hundredths, 7 hundredths, and 5 hundredths. So that's the smallest. 5/11ths is the smallest number. Now we've looked at the hundredths. Now let's look at the thousandths. So we've got 8 thousandths and 2 thousandths. So that's our next smallest number, 0.4727272 and so on. And finally, our largest number with 8 in the thousandths column would be 11/23. And that's it. So writing the numbers in order from smallest to largest would be 5/11ths, 0.472 with the 72 recurring, and 11/23. And that's it. Okay, let's have a look at our next question, question number 18. Okay, let's have a look at question number 18. So question number 18, we've been asked to work out 0.3 recurring, subtract 0.05 recurring, and to give our answer in its simplest form. So we've got 2 recurring decimals here. Let's convert both of them into fractions because we've been asked to give our answer as a fraction. Now 0.3 we've thought about, we know that's 0.333 and so on. That's a third. So we know that's a third already, so that's a third. And our 0.05 recurring, so 0.055555, let's change that into a fraction. So 0.05555 and so on, and that's equal to x. So we want to change that into a fraction, so let's times both sides by 10, so 10x is equal to 0.5555 and so on. So that's 10x, and that's great because we've got the recurring bit after the decimal point. Now let's times by 10 again, so that'll be 100x is equal to 5.5555 and so on. So that's great. We've got 10x is equal to 0.555. We've got 100x equal to 5.5555 and so on. So let's write that beneath the 10x and let's take them away. So 0.5555 and so on. So if we take those away from each other, so subtract, we get 90x, because 100x take away 10x is 90x, is equal to, and 5.555 take away 0.555 would just be 5. So that means that 90x is equal to 5, and that means that x is equal to 5 over 90, or 5/90ths. And we can cancel this down. They're both divisible by 5. So 5 divided by 5 is 1, and 90 divided by 5 would be 18. So that means that 1/18 is 0.05555555, and so on. So we've now got 1/3 subtract 1/18. So whenever we're subtracting fractions, it would be great if we had a common denominator. So we're 3 and 18. We want to find the lowest common multiple of 3 and 18. That's going to be 18. So let's change both the denominators to 18. Well, that was already 18 on the right hand side. So to get from 3 to 18, we would times by 6. So let's multiply the numerator by 6 as well. So that's going to be 6/18. So 6/18 subtract 1/18 would be 5/18. So that means that 0.33333 and so on, subtract 0.0555 and so on, will be 5/18. And that's it. And can we cancel this down? Well, no, that's it. Our answer is 5/18. And that's it. Okay, let's have a look at our next question, question number 19. So question number 19 says to work out 0.144444 plus 0.232323 and so on, and to give our answer as a fraction in its simplest form. So we need to change both of these recurring decimals into fractions. So let's start off with this one. So x is equal to 0.144444 and so on. Now that's x. Let's times both sides by 10 to get 10x is equal to 1.4444 and so on. And I've done that so we have the recurring bit after the decimal point. Now if we multiply by 10 again, we would get 100x is equal to 14.4444. That's great because we've now got two numbers with that recurring bit after the decimal point. So we've got 100x and we've got 10x, and that's equal to 1.4444 and so on. So we want to subtract them from each other to find out what x is. So we've got 100x, take away 10x, that's 90x. And on the right hand side we had 14.4444. We've got 1.4444. If we take them away, we're left with 13. So if we then divide by 90, so divide by 90 and divide by 90, we get that x is equal to 13/90ths. So that's what x is. So let's have a look at the other number, this other decimal number. Let's call this y. So y is equal to 0.232323 and so on. So we've got what y is, and that's great because we've got the recurring bit after the decimal point. So let's just multiply this by 100. So that'll be 100y is equal to 23.232323 and so on. So we've got what y is and we've got what 100y is. So let's write the y beneath it. So that's our 0.232323 and so on. And what's great is if we take them away from each other, the bit after the decimal point will cancel out. So we're left with 100y take away y would be 99y. And on the right hand side we have 23.232323. We take away 0.232323. So we're just left with 23. So we've got 99y equals 23. So let's divide by 99 and divide by 99, and we get that y is equal to 23 over 99. So that's fantastic. So we now know that 0.144444 is 13/90ths, and we know that 0.232323 is 23/99ths. So we now can just add them together to find our answer. So let's do that. So we've got 13/90ths plus 23/99ths. So in terms of a common denominator, I'm thinking 990. The reason I'm thinking 990 would be we could times 90 by 11 to get 990, and we could times 99 by 10 to get 990. Now there may be other common denominators you could use, but that's the one that I'm thinking of here. So I'm thinking 990 and 990. And again, the reason I thought of that was I could times 99 by 10, I could times 90 by 11. So we could times 90 by 11 to get 990. So we need to times 13 by 11 to find out what the numerator would be. So 13 times 11. So 10 times 13 is 130, and another 13 would be 143. So it'll be 143 over 990. And this fraction is a bit easier, where we times by 10 to get 990. So we need to times by 10, so that'll be 230. So we've got 143 over 990 and 230 over 990. And then we just need to add them together. So to add fractions, remember we just add the numerators, so keep the denominator the same, the 990, and we need to add together 143 and 230. So it's going to be 373. So our answer is 373 over 990. And I don't think we can cancel that down. So our answer is 373 over 990. Just check and see if they can divide them by 2 or by 3 and so on, or 5. I can't, so that's my answer. Okay, let's have a look at our next question. Okay, question number 20 says to work out 1.544444 multiplied by 0.2222222 and so on, and to give our answer as a fraction in its simplest form. So let's convert both of these recurring decimals to fractions. So let's start off with our 1.544444 and so on. So 1.54444 and so on, and that's equal to x. So let's multiply both of these by 10, so we get 10x is equal to 15.4444 and so on. Now we want another number with the 444, so I'm going to multiply if I go back up to our x, I'm going to multiply both sides by 100, so that'll be 100x is equal to 154.4444 and so on. So let's take these away, so the 0.44444's cancel out, so we'd have 10x is equal to, and then we've got 15.444 and so on. And if we subtract 100x take away 10x is 90x, and on the right hand side we have 154.444, we're taking away 15.444, so that would leave us with 139. And if we divide both sides here by 90, we're going to get divide by 90 and divide by 90, we'll find that x is equal to 139 over 90. So that means that 1.54444 and so on is 139 90ths. Okay, let's now have a look at the 0.2222222 and so on. Well, I know straight away this is going to be equal to 2/9, because 1/9 is equal to 0.11111111. So 2/9 is equal to 0.22222 and so on. So let's work this out and just show that. So if we let y equal 0.2222 and so on, 10y would be equal to 2.22222 and so on. Both of these numbers have that 22222 after the decimal point. So let's write down y equals 0.2222 and so on. And let's take them away. So subtract. So 10y, take away y would be 9y. And on the right hand side we have 2.222, take away 0.222, so that's just going to leave us with 2. And if we divide both sides by 9, divide by 9 and divide by 9, we get that y is equal to 2/9. So instead of 1.54444 and so on, we can write 139 90ths multiply by it, and instead of 0.2222 we can write 2/9, and we just need to multiply them together. So 139 multiplied by 2, so let's double 139, and double 139 will be equal to 278, because double 130 is equal to 160, and double 9 is 18, add them together, 278. And in terms of our denominator, we've got 90 multiplied by 9, that's going to be equal to 810. So we've got 278 over 810, and I just done 9 times 9, which is 81, and put my 0 on the end. So we've got 278 over 810. Now we need to cancel this down because it's in our simplest form. So halving both of these numbers would be 139, and half of 810 would be 405. And I think that's as far as we can go. So right now our fraction in the simplest form would be 139 over 405, and that's it. Okay, let's have a look at question number 21. So question number 21, we've been asked to work out 0.181818 plus a third, 0.333333, divided by 0.4666666 and so on. So let's change all of these to fractions because we've been asked to give our answer as a fraction in its simplest form. So let's change all these to fractions. So instead of 0.333, I'm going to write a third. That's a third. So let's now find out what this is, our 0.181818. So 0.181818 and so on. Let's call that x, so x equals. Multiplying this by 100, so we have another number with that 181818. So it's going to be 100x is equal to 18.181818 and so on. Now if we take them away from each other, we've got our x equal to 0.181818 and so on. And if we take them away, 100x take away x would be 99x, and on the right hand side we had 18.181818. We take away the 0.1818, we're left with 18. If we divide both sides by 99, we can write that as a fraction, so x is equal to 18 over 99. And actually we can cancel this down. Both of these numbers are divisible by 9, so 18 divided by 9 is 2, and 99 divided by 9 is 11. So that means that 0.18181818 is 2/11. So we've changed two of them into fractions. So let's then do our last one, our 0.46666 and so on. And perhaps earlier in this video I've maybe done this one already, but let's have a look at it. So y equals 0.466666. We want that recurring bit after the decimal point, so let's times by 10. So 10y equals 4.66666 and so on. So that's what 10y is, but we want another number with that 666. So let's go back up to our y and multiply both sides by 100. So that'll be 100y is equal to 46.666 and so on. So we've now got our 10y and our 100y, and we're going to subtract them from each other so that bit after the decimal point cancels out. So that was 4.6666 and so on. So 100y, take away 10y is 90y. And on our right hand side we had 46.666, we're taking out 4.666, that's going to leave us with 42. And dividing both sides by 90, divide by 90 and divide by 90 will give us that y is equal to 42 over 90. And that cancels down because both of these numbers are divisible by 6. So 42 divided by 6 is 7, and 90 divided by 6 is 15. So that means that y is equal to 7/15. So 7/15 is 0.46666 and so on. So that's 7/15. So we've now got our three fractions. We've got 2/11 plus 1/3 divided by 7/15. Okay, so we now need to work this out. Now, whenever I made this question, I've done this on purpose. We've got an addition and a division. So remember, whenever we've got divisions and additions, we need to do the divisions first, our order of operations. Some people call it BODMAS or BIDMAS, but we need to do the division before we do the addition. So we need to work out what 1/3 divided by 7/15 is first of all, before then we do the addition. So let's work out this division. So remember, to divide, we multiply by the reciprocal. So we've got 1/3 multiplied by 15 over 7. And 1 times 15 is 15, and 3 times 7 is equal to 21. So that means that 1/3 divided by 7/15 would be 15/21. So, and actually we can cancel this down. These are both divisible by 3. So if we divide both of these by 3, we would get 5 over 7. So we've done the division, so we now need to do the addition. So we need to do 2/11 plus our 5/7. And let's just work that out. So we want a common denominator. I'm going to go for 77. So 77 and 77. To get from 11 to 77, we times by 7. So let's times the numerator by 7. So it's going to be 14/77. And to get from 7 to 77, we multiply by 11. So multiplying the numerator by 11 would be 55 over 77. And now we just need to work this out. So 14/77 plus 55/77 would be 69/77. And that's it. And that can't be cancelled down, and it's a fraction, so that's fantastic. So we've worked it out. So 0.18181818 plus 0.333333 divided by 0.4666666 and so on would give us 69/77. And that's it. Okay, let's have a look at our last question. So our last question says, work out 3 to the power of negative 2 divided by 0.270 with the dot above the 2 and the 0. So that's 0.270, 270, 270 and so on. And we need to work that out, that division, and to give our answer as a fraction in its simplest form. So let's work out both of these values. So I'm going to start off with the 3 to the power of negative 2. So 3 to the power of negative 2 is got a negative power, so that means we do 1 over the positive power. So instead of writing 3 to the power of negative 2, that's the same as 1 over 3, and instead of being negative 2, we do 3 squared, so 1 over 3 squared. And 3 squared is 9, so that's 1 over 9. So 3 to the power of negative 2 would be 1/9. So that's 1/9, and we're going to divide this by 0.270, 270, 270 and so on. So let's change this into a fraction as well. So let's do that. So let's let this be equal to x. So x is equal to 0.270, 270, 270 and so on. Now we want that recurring bit after the decimal point, so that's great. We've got one number with that after the decimal point, that 270, 270, 270. And so now let's times this by 1,000. So 1,000x would be equal to 270.270, 270, 270 and so on. That's great. So we've now got two numbers with that 270, 270, 270 after the decimal point. So let's write the x beneath it. So 0.270, 270, 270 and so on. Now we want to take those away from each other so the bits after the decimal point cancel out. So let's do that. So let's take them away. Let's write subtract, subtract. So 1000x, take away x would be 999x. And on the right hand side we had 270.270, 270 and so on. Take away 0.270, 270 and so on. So that would leave us just with 270. And now we want to find out what x is, so let's divide both sides by 999. So divide by 999. And on the right hand side, that would leave us with x. And on the right hand side, we'd have 270 over 999. And that cancels down actually. We can see both of these numbers are divisible by 9 because 2 plus 7 plus 0 is 9. That's a multiple of 9. And 9 plus 9 plus 9 is 27. That's a multiple of 9. That means that both of these numbers are divisible by 9. So let's divide both of these numbers by 9 and see what we get. So 270 divided by 9. Well, 27 divided by 9 is 3, so that'll be 30. And on the denominator, we've got 999 divided by 9, so that'll be 111. Now actually, if you look at these numbers, they're both divisible by 3, because 3 plus 0 is 3, and 1 plus 1 plus 1 is 3. That means they're both multiples of 3. And so if we divide both of them by 3, the numerator, 30 divided by 3 is 10. And then in terms of our denominator, we've got 111 divided by 3. My shelter's a bit not straight. So we've got 111 divided by 3. Still not straight, that doesn't matter. So how many 3's go into 1? 0, remainder 1. We've now got 11. How many 3's go into 11? That'll be 3, remainder 2. And how many 3's go into 21? That's 7. So 111 divided by 3 would be 37. So we've got 10 37ths. So that means that 10 37ths would be 0.270, 270, 270, and so on. So that's 10 37ths. And in this question, we've been asked to work this out, so we need to work out 1/9 divided by 10 37ths. So let's do that. And I'm just going to change the color of pen here. So we're going to do 1/9 divided by 10 37ths. So remember, to divide by a fraction, we multiply by its reciprocal. So we're going to multiply by 37 over 10. So 1 times 37 is 37, and 9 times 10 is 90. And that's equal to 37 90ths. And that can't be cancelled down. So our answer would be 37 90ths. And that's it. So these have been the video solutions to the recurring decimals practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. If you need any extra help on recurring decimals, if you go to corbettmaths.com/contents and scroll down to video number 96, there's a video tutorial there on recurring decimals. I really hope you found this video useful. So if you have liked it, please like it, please subscribe to the YouTube channel, and thanks so much. Cheers. Bye.